Welcome back, geometry students. I'm hoping that your transformations, your reflections, your dilations, your rotations, your translations all went okay with the end of chapter 9 there. And now we're going to do a little vectors that we're going to add to it when we take the test over this section. So this is kind of a standalone, but we'll kind of group it back in with what we did for chapter 9. So we're starting vectors here. I do want to tell you I'm giving you a very, very small introduction to vectors. There's so much you can do with them. There's so much they're used for. But I do want to introduce you to them so that maybe later when you see them again, you'll say, hey, I remember some of that. So the first thing I want you to do is just look at my vector that I have drawn here at the top of the page. And sometimes when I show this to students for the first time, they say, well, wait, that looks like something else we've done this year. Well, when I look over there at that line that has an A and a B, a dot on one end and an arrow on the other, some kids say that looks like a ray. So we did do rays when we were way back in chapter 1, and we've seen them before. 2 rays make an angle, things like that. But we're actually looking at vectors today, and they can be easily confused, so I just want to kind of state a few things about each one so you know the difference between a ray and a vector. If you remember with a ray, when we did that back in chapter 1, rays were just, it started with a point and it went on to the arrow. And technically that arrow goes on and on and on forever. Okay, so one of the things with rays is they never end. So because they never end, we can't measure it. Okay. Now, when we start with vectors, though, one thing I want to point out, the vectors do end. Okay, so they do come to an end, and in fact, they end right where that arrow is. And because they end, you can find its size. So with both of them, though, when you think about them, they both start with a point. And they go to that arrow. So in that way, they're the same. They look kind of the same, but we're definitely going to see a difference with vectors today than we saw with rays before. One other thing I want you to kind of know, when you see this vector here, notice this is on a grid, but I don't have any numbers on this grid. It's not a coordinate plane. I don't start at like 2, 4, and I go to another point or anything like this. This is going to be different as we go through with our vectors, but you're often going to see them on a grid so that we can actually work with them, but it's not the coordinate plane. So let's go through some of our definitions. Now, one thing I do want to state, your paper is blank, and my notes obviously have all these definitions filled in. If I go too fast through these, don't forget, you can always stop the video, pause it, copy down what you need to, and go from there. But for sake of keeping this video as small as I can, I'm going to keep moving, and if I move too fast, don't forget, you can pause the video. So the first thing I want to talk about with a vector is its definition. And this is a quantity that has both direction and magnitude. Okay, so the direction you see is the arrow, and the magnitude will be its size. Because it actually ends, we can find its magnitude or its size. So a vector is a quantity with both direction and magnitude. And just a heads up, that's a test question, so you do want to remember that. So when we look at this vector, it has an initial point, the starting point of a vector. So just so you know, every time we see a vector, it's going to have a starting point, this initial point. It has an arrow here, and we're always going to have some kind of a name on it. I'm going to call this one RS. So in this one, point R is the initial, because that's where it starts at. And I'll call it the initial point so we don't forget that. So our initial point is where a vector starts. When we get to the terminal point, that's the ending point of the vector or the arrow. Okay, so if I start here and I go this way, here's X, here's Y. So in this case, Y is the terminal point. Okay, if you think of the word terminal, it means ending. So something that ends. So the terminal point is the ending of the vector. Moving our page up here. I have the horizontal component. So the horizontal component is the distance left or right a vector goes. So just so you know, when you're given a vector, Okay, there's going to be something that's drawn. We always go horizontal first when we go to identify it. So this point here, and then we kind of go up from there. So this distance from here to here, that's the horizontal, okay? And we're going to actually have a value on that, a number that goes to that horizontal. And then your vertical component is the distance up or down a vector goes. And just so you know, as we go through these vectors, we always start at the initial point. We always go left or right first. So we always do our horizontal first, and then we do our vertical second. So this right here is my vertical. Okay, so the one that goes up or down. Okay, and then we have this component form, which it looks like didn't show up here. So one thing I want you to know with component form is we have this, what I call pointed parentheses, okay? And that's going to be your big hint that you're working with a vector, is you're going to see these pointed parentheses. And we're going to have an H and a K in here. This component form combines the horizontal and the vertical components. It tells us where the vector is actually going. So inside this pointed parentheses, the H actually tells us left or right. So if it's negative, you're going to go left. If it's positive, you're going to go right. And then there's a comma, so it looks a lot like an ordered pair. And then it gives us how far up and down it goes. So obviously if it's up, it's positive. If it goes down, it's negative. And that's my kind of my code. My component form is my code for how my vector is going to move. I am going to be picky on these pointed parentheses, so when you write vectors, you're going to need these pointed parentheses instead of a regular set of parentheses. If you have the regular, it looks like an ordered pair and you find a point, but this one's actually going to give us directions on drawing our vectors. So let's move to page 2. So once again, I have quite a bit written here that's not on your note sheet. So again, feel free to pause the video and copy it down if you need to. So we're going to practice naming a vector and writing its component form. So one thing I want to kind of remind you, and this is another difference between an array and a vector. I'm going to change colors on here so I can show up a little bit better. Okay, when we named array, if you remember, we would name 2 letters like A, B, and then we would put a line with the arrow on one end, saying it started at A, went through B, and kept going. Now when we name a vector, if it starts at A, the initial point, and it ends at B, I'm still going to write those 2 letters, but I'm going to write this line, and then it has half of an arrow. Okay, some kids call it a harpoon, something like that, but a vector uses half of an arrow. The array uses that full arrow. So when I go to name these vectors and write their component form, notice on my blue note it says name starting at the initial point, going to the terminal point, and use that half arrow above it. So on my first one here, you can tell my initial point starts down here at J, so J is my first letter, and it goes to M, and then I put my half arrow above it. For my second vector over here, it starts at X, and it goes to Y, and I put the half arrow above it. And finally, on my third example over here, it starts at D, it goes to R, and I put my half arrow above it. So that's the name part of my vectors. Now we're going to work on the component form, and that's this red note underneath my names. It says when writing the component form, always move horizontally first, vertically second, terminal point. Now remember, when we write this component form, we want those pointed parentheses. So I'm going to start at J, and I'm going to move horizontally and then vertically until I can get to M. It's kind of like counting our slope, but the key is here, be careful and make sure you go horizontal first and vertical second. So from J, I'm going to count 1, 2, 3, 4, 5 to the right. Because it's to the right, it's positive. And then I go up 2, so that's also positive. So my component form for vector JM is 5, 2. When I am at XY, remember horizontal first, vertical second. So from X, I'm going to count 1, 2, 3, 4, and that went to the left. So make sure you make that a negative 4, and then it's going to go up 1, 2, 3. Up is still positive, so I get the component form of negative 4, 3. And on my final one for DR, I start at D, I go horizontal first, so 1, 2, 3, 4, 5, 6, 7, and that went left, so that starts out -7, and down 1, 2, 3, and that's going to be a -3. So there's my component form. I should probably write my other numbers over here for somebody looking on. So component form is actually kind of a direction. How far do I go left or right first, and then how far do I go up or down second? And so those component forms are the code for how my vector actually goes. So as we look here on our next part of our notes, the key to these vectors are each vector has two components, the magnitude and the direction. Magnitude is the size of a vector, so how big the vector is, how long it is. Now, one thing I do want to state out is there's not one unit that we use for vectors, because vectors can stand for lengths, force, speed, all kinds of things. So maybe your label on it is feet, maybe your label on it is newtons, maybe your label on it is miles per hour. So the magnitude is just how big that vector is. And the direction is the angle of the vector from your starting point, and it includes the direction. So just a quick note for this direction part. When I say direction, I'm talking just looking at a compass. So here's my north, here's my south, here's my west, here's my east. So if I say, well, what's the direction of that vector? Well, if it's going this direction, you would tell me that vector is southeast. If it's going some other direction, you'd say northwest, or whichever direction it is. So there's actually two parts to every direction. It's going to include an angle and the northeast, southwest, whatever the other part of that direction is. So we have one more problem here on the bottom of our page of this notes. And this says to draw and find the magnitude and direction of vector RS, which notice in those pointed parentheses are 7 and -2. So we're going to go ahead and sketch this vector. So I'm just going to start with a point here, R, and I need to go 7, -2. Well, 7 is positive, so I'm going to go to the right 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go -2, which goes down 2. And right there is where S is. So my vector starts at R and it goes to S. There's my vector. Now I have two things I need to find. I need to find its magnitude and its direction. So again, you'll notice I already have these pop-up notes that are there. You're going to want to do this. But when I go to find the magnitude, I'm looking for how long is this vector right here that I just drew. Well, remember, I went to the right 7 and I went down 2. And I have this little right angle here, so it makes a nice right triangle. That means if I'm trying to find how long this is, I can use a little Pythagorean theorem. So I'm looking at a squared plus b squared equals c squared. And it looks like my most important one, what is c? Well, c has to be my hypotenuse, so that's my x. And I can put my 7 and my 2 in my other two spots. 7 squared is 49, 2 squared is 4. 49 and 4 make 53. And because I don't give you any other directions, we can go ahead and get the decimal here. We don't need a simplified radical. And plug that into your calculator. The square root of 53 is about 7.3. So that's my magnitude, the size. On a quick side note, I do want to do this. Magnitude, depending on what you're using, sometimes you're going to see this little thing right here. So vector RS, and it has these double lines around it. That symbolizes magnitude. So if you see the double line, it's saying what's the magnitude of RS. So my answer to that would be that 7.3 we just found. So just a quick note, I do believe on one of the review sheets or something, I may have those bars around some letters, and I just want you to know that stands for magnitude or the size of that vector. So we have the magnitude done. Now let's look at the direction. So the direction, it says angle, and the angle is right in here. Let me change our color so we can see this better. So I'm looking for this angle right in here. One thing I want to note is anytime I'm looking for the angle is always at the initial point. Okay, so don't put that angle down by the arrow ever. Always put it at the initial point. And remember, from the initial point, we always go to the right first or left first and then up or down from there. So always go to the initial point to find that angle. So I'm looking for this angle. And if you think about this from back from chapter 7, it looks like in this right triangle, I know my opposite over here. And I know my adjacent. I know I just found my hypotenuse, but it's a decimal one I found. I probably don't want to use that. So it looks like if I'm working with opposite and adjacent, I'm going to use TOA, tangent. So tangent of my angle equals the opposite, which is 2, over the adjacent, which is 7. So if we remember from chapter 7, if I'm looking for a missing angle or I'm trying to get this theta here all by itself, I need to get tangent off of it. Well, what undoes tangent? That would be the inverse tangent is its opposite. So I take the inverse of both sides. These two cancel, and so theta is going to equal the inverse tangent of 2 over 7. So make sure your calculator's in degree mode. Go ahead and hit inverse tangent of 2 over 7 and find your theta. And your theta should be 15.9 degrees. That's only half of our angle, our answer for direction. The other part we have to put is our compass setting. So if I think about this here, this is definitely pointing down to the right, and that would match my southeast. So that's the second part of my direction. So 15.9 degrees to the southeast is my direction, and my magnitude over here was 7.3. And those are the two things I'm looking for every vector that I'm drawing. So that's the full notes today. You have a homework worksheet of vector sheet 1. There's 2 of them, and it should say at the top, probably written in handwriting, is vector worksheet number 1. And you're going to try that. The front side looks a lot like this question we just did here on the bottom here. You're going to find the magnitude and direction of every vector on the front side. And actually, it looks like the back side. I think it starts with number 5 through 10. And then you have some story problems that try to just do your best on the other side to put a vector to each of those story problems, and we'll go from there. If you have questions for me, let me know. Email me, write it on the stream, and I'll try to get back to you as soon as I can. Thanks for listening.